Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x plus 3 to the power of x minus 1 plus 3 to the power of x plus 1 is equal to 2. Now, our first property that we are going to use to solve this problem is that if we have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So as you can see here, we have 3 to the power of x plus 1, and this is going to be equal to, we can say that a is 3, x is equal to m, or sorry, x is not equal to m, x is equal, m is equal to x, and n, this is equal to 1. So if we plug these in, we get 3 to the power of x plus 3 to the power of x minus 1 plus 3 to the power of x times 3 to the power of 1 is equal to 2. Now we have a to the power of m minus n. And many of you out there probably know that a to the power of m minus n, this is equal to a to the power of m over a to the power of n. However, we are not going to be using this property this time. We're going to be using, well, if a to the power of m plus n is equal to a to the power of m times a to the power of n, right? Then this means that a to the power of m minus n, this is equal to a to the power of m times a to the power of negative n. So 3 to the power of x minus 1, this is going to be 3 to the power of x times 3 to the power of negative 1. Now we are adding this with 3 to the power of x times 3 to the power of 1 is equal to 2. So now I'm going to factor out 3 to the power of x. So now I have 3 to the power of x times, now 3 to the power of x divided by 3 to the power of x is 1, plus 3 to the power of x times 3 to the power of negative 1 divided by 3 to the power of x, that's simply just 3 to the power of negative 1, plus 3 to the power of x times 3 to the power of 1 divided by 3 to the power of x is simply just 3 to the power of 1. So now this is equal to 2. Now I'm going to simplify this a little bit. We have 3 to the power of x times 1 plus, now 3 to the power of negative 1. If we have something in the form a to the power of negative 1, this is equal to 1 over a. So 3 to the power of negative 1, this would equal 1 over 3. Now we're adding this with 3 to the power of 1, which is the same thing as just 3. So now this is equal to 2. Now I have 3 to the power of x times, now 1 plus 3, this is equal to 4. So I have 4 plus 1 over 3. So this is equal to 2. Now 4 plus 1/3, this is equal to 4 over 1 plus 1/3 equal to 2. And now we can use cross multiplication. These two. So I will have 3 divided by 4 times 3 is 12, plus 1 times 1 is 1. This is equal to 2. Now 12 plus 1 is 13, so I have 3 to the power of x times 13 divided by 3 is equal to 2. So now I can simply multiply both sides by 3. So I have 3 times 3 to the power of x times 13 over 3 is equal to 2 times 3. So then these 3's will simply cancel out. So I will be left with 3x times 13 is equal to 2 times 3 is 6. Now I can divide both sides by 13 because we want to isolate x. So I have 3x times 13 divided by 13 is equal to 6 divided by 13. Then these two will simply cancel out. So I will have 3 to the power of x is equal to 6 divided by 13. And now to solve this problem, I can take the log on both sides. So I'll have log 3 to the power of x is equal to log of 6 over 13. And an important property of logarithms is that if we have something in the form log a to the power of b, we can actually move this exponent b to the front of the logarithm. So this will be equal to b times log a. And this property is extremely useful for when we have instances such as these, where we have log to the power of 3 to the power of x, because I can simply move this exponent x to the front of the logarithm, and now this would be equal to x times log 3, and now before x was an exponent, and now it is a term, so now we can actually find the value of x, because before when it was an exponent, it was really challenging. So now we have x times log 3 is equal to log 6 over 13. Now I can divide both sides by log 3. So now I have x times log 3 over 3. These two would cancel out, so I would have x is equal to log 6 over 13 divided by log 3. Now if I have something in the form log a over b, this is equal to log a minus log b. So log 6 over 13, this is going to equal log 6 minus log 13. So now I have this over log 3. Now, log 6, this is equal to approximately 0.7782. Log 13 is equal to approximately 1.1139. And log 3 is equal to approximately 0.4771. So now if I plug these values into our equation here, we get x is equal to 0.7782 minus 1.1139 divided by 0.4771. And if I simplify this, 0.7782 minus 1, negative 0.3357 divided by 0.74771, and this simplifies to negative 0.7036. So this is our answer. And now